So we've talked about finding probabilities given a z-value. So these are problems we've looked at where we were given a z-value and we found the area. But what if we know the probability and we actually want to work backwards? For example, what if we know that the probability that z is below some z-value, we don't know what it is, we call this z naught, and that area or probability is 0.1230. So this is telling me that I have a 12.3% chance of falling below some value. So when I think about my normal curve, let's see, that's a small area, so that's below 50%. So that's probably down here somewhere. This is my z naught value. I don't know what it is, question mark. And the area here, I do know that area is 0.1230. And so my question is finding that z-value. Well, okay, if that's what I want to do, I want to work backwards. I can still use my table. In this particular case, I know that that z-value is on the left-hand side of 0. So I want to think about using the negative z-scores. Okay? And so using the negative z-scores, but this time I'm working backwards. The area 1.230 is in here, and then I want to work backwards and find the z-score that goes with it. So let's see if we can find that. So looking at my chart, trying to find 1.230. I think I spotted it. There it is, 1.230. And that corresponds to negative 1.16. Negative 1.16 is the z-score that marks off a lower area of 0.1230. Negative 1.16. So this value right here is negative 1.16. So it turns out that that answer that I'm looking for, the z-score I'm looking for, is negative 1.16. Or the probability that z is less than or equal to negative 1.16 is 0.1230. Okay? Let's try another one. Let's look at here. Okay? Let's suppose we want the probability that some lower value or z is below some value, and that's 80%. So we're finding 80%. Well, let's see here. Again, let's see. This is 50% below, and so 80% has to be somewhere up here. So where we're talking about all of this is 80%. So again, we know the area. Probabilities are areas. Let's not forget that. Probabilities equals area. And in this case, the probability was given. So we're given the area. And we're working backwards to find the z-score. So we're working backwards to find that. Well, good news. My chart reads left-hand areas. So the good news is I'm going to go to my chart. This time, of course, I'm on the right-hand side of 0, so I want to make sure I'm using the correct page of my chart. So I'm going to go to the page that shows values above 0. Right? So the positive z-scores. And I'm looking for 0.80. Well, 0.80. 0.80 I don't find. So the bad news is I don't find 0.80 exactly like I did last time. This time I have to think about where 0.80 falls closest. So I see that I have two values. I have 0.7995 and 0.8023. So when I think about a number line, let's see. Let's think about those two numbers. 0.7995 and let's see, the other number was 0.80, 23. 0.80 is a lot closer on a number line to 0.7995 than it is to 0.8023. So I'm going to go with this one. So unless it lands exactly halfway between, I'm going to go with the one that's closest. That's the rule of thumb generally we follow. There are people who do other things, but that's what we're going to do. So I'm going to go back to my chart, and I'm going to look at the 0.7995 value and see that that corresponds to a z-value of 0.84. Now don't get confused. This is similar to our area, but that's actually the z-value. The z-value is 0.84. My picture, 0.84. So my original picture up here is not really drawn to scale. This should probably be a lot closer. It probably should be a lot more like in here, but that's okay. It doesn't have to be. So what do I know using this information? The probability that z is less than or equal to a z-value of 0.84 or 0.84 standard deviations above the mean gives me an area of 0.80 or 80%. All right, another example. Here we go. All right, well, this looks very familiar. Let's see. Probability that z is greater than some or equal to some number is 0.62. But the difference here is that I want something greater than or equal to. So let's see. Thinking about that with my pencil because it's easier to shade. Greater than the mean here is 50%, right? This is 50. So I'd have to go on this side, kind of like we did up in this problem, but we went that direction. I have to come over here somewhere to get a z-value that I don't know, whose area, this area here, is 0.62. Again, they're giving me the probability. So it's important to be able to read this sentence and know that this here is the probability. Okay? So that's the area. All right, well, wait a minute. My chart, when I go to my chart and I look at it and I look at the right page, I want to be on the left-hand side of the mean. I also know my chart reads left-hand areas. I can't do this. I got to stop a second and think. I want a right-hand area 0.62. But my chart reads this area. So I'm going to need to think about it, and I need to find this area first because that's when I need to look up. So I need to do 1 minus 0.62, which is 0.38. So 0.38 is this lower area, and that's what I need to be looking up or find the closest to if I can't find it exactly. 0.38. All right, so not 0.62 because, again, that's upper area. So let's go down here on the chart. And you have to be careful, too, because sometimes you get suckered into picking something like 0.038, and you don't want that. So don't be looking at these numbers here. So we want 0.38. Oh, I need to move my paper up. Let's see, 0.38. Now there's 3859, 3821, 3. Okay, so here we go. We're between these two right here, 0.3821 and 0.3873. So we're between 0.3821 and 0.3783. And I put that one to the left because on a number line technically it'd be to the left. So 0.38, where does that fall? So if you think about it, right, that's 0.0021 you would have to add to get to this one. And you can use a calculator, but you would have to subtract 0.0017 to get to this one. So it's closer, not by a lot, but it's closer to this one. Happens to be two problems in a row that were closer to the lower one, but that won't always be the case. Okay? So we're closer to the 0.3783. So going back to my chart, I didn't even look to see. So in this case, it's actually the one on the right that I want to be using, 0.3783, which is the lower number, and that's negative 0.31. Negative 0.3, and then of course the 1, which is the decimal place up there. Okay? All right. So my z value now, right here, is negative 0.31. That negative is important, so let's not lose that because it's on the left-hand side. So what do we have? We have the probability that z is greater than or equal to negative 0.31 standard deviations, or 0.31 standard deviations below the mean, and that gives us an area or probability of 62%. Okay? Makes sense? So we have one more type of example we want to look at. We've looked at areas to the left. We've looked at areas to the right. What happens if we look at areas between? So let's say, for example, we're in manufacturing or something else, and we want to find the probability that something falls between two numbers and it's the middle 70%. Okay, so between two numbers gives us 70%. So, for example, we're talking about there's some number down here and some number up here, and we always assume these two are the same, like that they're evenly distributed. They're not uneven. That would only be if we were talking about the empirical rule or something like that. We're looking, but here this is assumed that they're equally distributed. That it's the middle. That this middle area here is 70%. Okay. Matter of fact, I already know. I probably didn't draw this quite to scale because if I go one standard deviation to the other side, that's 68% according to the empirical rule. So this is a little bit beyond one standard deviation to either side. So probably these lines should be a little bit further over, but again, they don't have to be drawn to scale. All right. But that's helpful for me to know. I already have a sense that this is probably like one-ish standard deviations to either side. How do I look this up? I know I need to go on the inside of my chart. I need areas on the inside. Areas I go on the inside and I work backwards, but I need a left tail area to look it up. So the easiest thing to do is to figure out what this left tail area is. And then whatever that z-score is, the lower one, I'm going to have an upper one as well. Those will be opposites of each other, like positive and negative 1.2 or something, or whatever it might be. And I completely made that up, but I already know it's 1 point something. So let's see. So let's see. If this is 70% and the whole thing is 100, then that leaves 30% for these tails. And if I divide those in half, that leaves 15% for each tail. So this tail here is 15%, and this tail here is 15%. So I can now look up and find closest to 15% and find that lower value. So let's do that. So looking up, again, 0.15. Looking, and it looks like it's down here. I just had it. Oh, here it is. Between these two numbers, 0.1492 and 1515. We're closer to 0.1492. And so, yeah, a lot closer to 1 and negative 1 than I thought. Negative 1.04. Negative 1.04. So this one is negative 1.04, which will make this one positive 1.04. So I know the probability that we go 1.04 standard deviations below the mean and 1.04 standard deviations above mean, and we will have captured 70% in the middle. And that's basically the three types of problems: a left tail, a right tail, and a between, an evenly distributed between, or an evenly set between, going backwards, where we have the area and we work backwards to find the z. Hope that helps.